Imagine a drop of water, a tiny droplet. Now, picture that droplet as big as a whole galaxy. Yes, you heard that right. In the vast expanse of space, there are water molecules so large, they defy everything we thought we knew about the cosmos. What if I told you that these water molecules could hold the secrets to our very existence? Stay tuned, because what we're about to uncover might just change the way you think about space forever. Water, one of the most essential substances for life on Earth. We've always known that it exists in space, but not like this. In fact, there's a type of water molecule out there, far beyond our reach, that's, well, mind-blowing. You might be asking, how big can a water molecule actually be? The answer might shock you. Scientists have discovered gigantic water molecules in space, particularly in the form of water vapor in distant clouds that are as large as entire galaxies. These molecules, known as H2O clusters, exist in some of the most extreme environments of space, inside massive gas clouds, far away from our little corner of the universe. How is that even possible? Well, let's break it down. On Earth, a single water molecule is made up of 2 hydrogen atoms and 1 oxygen atom. But, in these cosmic environments, water molecules can combine with each other, forming vast clusters, creating chains that stretch out over unimaginable distances. These molecular clouds can be the size of entire solar systems or, in some cases, even galaxies. Now, picture this. Inside these clouds, molecules of water can reach sizes that are unfathomable to us. A cluster of water molecules might be tens of millions of miles across, just like the size of some galaxies. And the most fascinating part? These clouds are not only filled with water molecules but also with complex organic molecules, some of which could be the building blocks of life itself. These water molecules are found in some of the most extreme environments in the universe. They can survive in temperatures below -400 degrees Fahrenheit, existing in the coldest reaches of space. Yet, despite the freezing temperatures, these vast water clusters hold the key to understanding the origins of life. These molecules have played a role in the creation of life as we know it. Here's the kicker. If these water molecules can form in space, they could have traveled across the universe, eventually landing on distant planets or moons, seeding life in the process. Some scientists even believe that water molecules, like those we're talking about, could be the cosmic travelers that carried life's building blocks to distant worlds. In fact, scientists have already detected signs of water vapor in the atmospheres of exoplanets. These distant planets could harbor oceans, lakes, or even rain, just like Earth. And where there's water, there's the potential for life. The discovery of these massive water clusters has huge implications for our search for life beyond Earth. What if we're not alone in the universe? What if, out there, in some faraway galaxy, there's another world, teeming with life, life that began just like ours, with water? So, when we think about space, we need to stop seeing it as a barren, lifeless void. What we're learning is that space might be more alive than we could have ever imagined. Water molecules as big as galaxies, what else could be out there waiting to be discovered? Could these colossal molecules be the key to understanding the origin of the universe itself? And, could life beyond Earth exist in forms we can't even begin to imagine? These are the questions that drive scientists to explore space, and they are questions that might one day change the world as we know it. So, next time you gaze up at the stars, remember this. the universe is filled with mysterious water molecules, gigantic, ancient, and possibly the secret to life across the cosmos. And as we continue our exploration of the universe, there's no telling what mind-blowing discoveries await us. If you enjoyed this journey through the cosmos, don't forget to like, subscribe, and share. We're just getting started.